Hello and welcome to my C64 Dither Lab. I have done a little video previously on just the regular Dither Lab. Uh, this one was, it's very challenge and very niche. So I separated this into its own library that also makes use of the same plugin architecture to introduce dithering specific to the Commodore 64 constraints back in the day. I mean, it's still constrained if you use the Commodore 64 or an emulator. But so I loaded a picture and automatically it squished it down to this 320 by 200 pixel resolution. That is intentional. The Commodore 64, it could not deal with higher screen resolutions. In fact, this is a high resolution on that platform. Anyway, what we have here is the ability to convert an image today into the best thing we could do back on a Commodore based on the constraints that I had available. But I have different modes and techniques to use. So the first was just using the blocks available in the PETSCII glyphs. And so we get a very blocky version of me. Now I do have this ability to apply a Bayer dithering before the Commodore dithering is applied, which does help sometimes, but we'll see what it does. And you can see progress bars. Not much of a difference here. The progress bars are needed because some of these take a long time processing. Okay, so we got a slash. Okay. And we are limited to 16 colors, and we can't change those colors. So that was another constraint of that platform. The next one would be the default character set. I should probably order these to make more sense. And this makes use of all characters available that you can use from that character set. And it looks like it used 30 of them. It got a little bit more detail of the frames in the back and the hair and part of the face. So that's good. And that's with the Bayer dithering. Let's get rid of the Bayer dithering. See if that changed anything. Not much. All right, let's go to the shifted business character set. Some people call it shifted character set. Some people call it business character set. It looks about the same. There we go. Looks about the same. Okay. Now we're going to go with the tough one. And this is a custom character set. In a custom character set, you could actually define what your characters look like. And we're not getting much out of here other than we've got more fine detail around the lips and the shirt. I'm surprised it only used 98 glyphs in all. However, I will use the dithering before I process it and see if that helps encourage the glyph sheet to populate itself. There we go. Wow, there is not much there. The character set also has this accuracy versus variety slider. Oh, it's a little different. What this does is, first, there are 1,000 blocks created for each character, or for each cell. And then we need to reduce those 1,000 blocks down to 207, or 256, which is why I'm very confused why there's only 207 glyphs. So since there are only 207 glyphs used, this has no effect. That's pointless. Because this only applies if there's more than 256 blocks. And it'll start trying to reduce those blocks down to that number, favoring either variety or accuracy. So that's that. I can't really show you much going on with that one. Let's go into the high-res bitmap mode. I think we'll see the most out of this. There we go. These are, wow, that is pretty impressive. So the bitmap mode is actually constrained not only by color, but each 8x8 pixel or 8x8 cell is limited to only 2 colors. So you can see kind of like a square cut off with the brown up here and the black over there, because it has to choose between 2 colors in each 8x8 cell. Let's apply our Bayer dithering before we do that. There we go. Look at that. That seems more true to form. And the blocks now are more pronounced. So you have white and gray blocks on the forehead, red and gray blocks around the most of the skin tone colors. All right. Let's go to multicolor bitmap mode. Multicolor bitmap mode is interesting in that you have to have a global background color, and each 8x8 cell can actually have up to 3 colors, but in addition to the global background color, but your pixels are a little bit wider. You can see up here in this area, any pixel on its own is actually 2 pixels wide. You will not see a 1x1 pixel in this final image, because to get to the multicolor bitmap mode, to allow for those additional pixels or the additional colors, the existing pixels that are used in each cell had to be widened so that they would use less bytes to make more room for the color. So instead of 4 bytes describing an 8x8, instead of 8 bytes describing an 8x8 cell, you have 4 bytes describing that 8x8 cell. Fun stuff. Let's do the apply dither. So it's the dithering. You can see the pixel widths more, but so the multicolor mode, I think, is actually smaller. Let me think on this. Is it smaller? Yeah, because there's less bytes needed to describe the bit mask of the image. But there is an extra byte for each cell to describe the additional colors. But everything is based off of memory. How much memory do you need for each of these? Not only memory, but where your storage is. How much storage can you put on your disk? And then how long is it going to take to load from that disk? Because each sector on a disk could only hold 254 bytes at most of the data that you needed, and then you had the seek time to get to the next sector, and there's a lot of techniques going on with that, but you did not want to have too much data on your disk to represent an image. There are techniques that you could have done to make the image maybe smaller, or only half the page, or half the screen, and then have like regular text on the side here. It says something. But yeah, that is this is what I'm using for my Commodore 64 images to create pretty much ebooks right now, and this helps me with taking care of any of the graphic content in the ebooks. And that's more like an Easter egg kind of thing. But now that I have it, I can use it for little games as well, or whatnot.